Okay, it's Dr. Banning. This is class Com 400, and we are going to do a video now on sampling, continuing sampling, and we're going to be looking at sampling size. Is a bigger sample actually better? Well, sometimes it is. All things considered, the bigger you go with the sample, the more it's going to represent the population. So an example would be if you had I'll say you had a cup of something here and you want to sample it. If you took a small size spoon, took it, I would give you a little bit of a taste. You'd find out more about it if you took a larger sample, took it, and if you had this, you would have a much more better idea of whether it was sweet, sour, if there were patches that were bad, etc. So that's an example of a sample size. Another would be here if you had some peanuts here. If I were to take one of these delicious generic peanuts, tastes pretty good. How do I know there's some of the others aren't bad? Well, if I took another, number 2, I've now doubled my sample size. Oh, that's pretty good. So I could keep going. The more I ate, the better it would tell me. The more it would tell me about the population. The more sure I would be about that. In experiments, however, even though a bigger sample size is better in experiments, as you go up, the amount of difference it makes is not that great. So the difference between in how effective the sample size is between 400 units and 1,000, say, people, isn't that great. So we're a lot of times we're going to go for 400, and you often see experiments with about that many, or studies with about that many. Sample size determinants. What are some things that actually determine sample size? The first one is method. The method used. For instance, a pilot study, and you might use 50 or less. Pilot study is not a study on pilots. I'm sure you know that. Pilot study is just a study that you're doing to as a test study for a bigger study. So you might just have 50 or less, just as it's like a prototype study. Also, talking about the method used, qualitative studies usually use fewer than experiments or quantitative studies. So an example would be focus groups, which use 6 to 12 people, usually in that area. You have in-depth interviews, which will use 12 or lower. And let's see if I missed any. I think those are the two things that I was going to, two examples I was going to give on method used. Now, cell size is another determinant of how big you want the sample to be. What is a cell? A cell is just something you want to study. For instance, if you wanted to study the difference in something between men and women, you would maybe have 20% men, 80% women, and you would have other categories, but we'll just leave those broad categories. You have other legitimate categories in there that people would be. But for, say, you were just looking at the men and the women, people who identify as that. And so if you had each of those cell sizes, because you have two things instead of you're looking at one, you would need to have a larger sample size. So the more things that you're looking at, maybe you want to look at, see if eye color affects how sunburned you get. Actually, it does, strangely enough. But if you were studying that, that would be one of the factors that you would look at, and so that would be an example of a cell size. And the more you have, the more things you're studying, the bigger your sample has to be. Let's see what else. Cost and time considerations. The more money you have, the more people you can try to get, because it costs money. Every person you get costs money. I hear about these studies that have 5,000 people, and I just wonder how many millions of dollars literally it took to get that. When I was doing my graduate work for my PhD, I looked and I had the number of people I wanted to get originally would have cost $5,000. I didn't have that, so I went for the number of people it would have cost me to get for $1,000. I didn't have that either, but it was the amount of not having it was a lot less. So cost and time considerations are very, very important. Multivariate studies. Now we talked about cell sizes and studying different things. Multivariate just means a variable is just something you're studying. So maybe you're trying to find out how factors affect you when you're studying. So maybe you would look at time, how much time you had, and that would be a variable. Maybe you look at temperature. If the temperature is not comfortable, it's found that people don't study as well. So that might be another variable. Whether you have a roommate would be a variable. Sometimes a roommate can help. All of the ones I had when I was in college were nice people. Some of them were a lot of fun. I don't think any of them helped me study. So those would be things in a multivariate study you would look at, and the more of those things you have, the bigger the study you have to the study has to be. The more bigger sample size you have. Okay, a couple of other things we will look at. Central Limit Theorem is one of the things that we wanted to talk about. And I'm going to read you the book definition here because we need to look at that very carefully. It's different than some others, but it covers basically the same thing, but it has every word's important. It says the sum of a large number of independent and identically distributed random variables has a normal distribution. Basically, that means that if you get a group if you're looking for a characteristic on things you would expect to have a normal distribution, which is generally behaviors and attributes of people and sometimes animals as well, you are going to have a normal distribution. Now, what is a normal distribution? We'll tell you in a minute. Not everything has a normal distribution, but the Central Limit Theorem says that, and it's usually with people or animals, behavior, etc., attributes, you'll have a normal distribution. Now, what is a normal distribution? We'll talk about one other thing. First, the distribution of values makes up the normal curve. And so the Central Limit Theorem says that it makes up the normal curve. And you might have heard that before, maybe not. But you might have heard about something called the bell curve. And the bell curve, what shape is the bell curve? It's the shape of a bell. It looks like, let me see so you can see it here. Here we go. It goes like this and goes down here. And basically what it says is, for most attributes, you have people where the bell is small. You have a few amount of, you have less of an ability to do something. As you get to the average is in the center. More people are at average. And then at the other end, you have fewer people who are also extremely good at something. So if you were to take basketball, there are not many people who can't pick up a basketball, but most of us are in that center area where maybe we can shoot it a little bit, but we're not going to be in the NBA. And then you have Michael Jordan on the other side and all the greats. And so, and of course on that other side too, you have your people who are very athletic and doing collegiate sports and things like that. And then after that would be the really legendary players. And sometimes those collegiate people move into that as well. So, but that's what it's talking about. The normal curve, not as scary as it sounds, but something you should know about. Normal curve, also called the bell curve. One other thing that we'll talk about is weighting. It's also known as sample balancing. And what this says is that a sample is statistically weighted to make up for unequal population percentages. Now that's the book definition. Let me tell you what that actually means. It means that, say you're trying to find out, you're talking to people who are going to graduate school and people who are not going to graduate school. And you want to see what the differences between those people are, if any. And so you talk to both of those people, and if it works out that there's 50% on one side and 50% on the other, great. What happens if you have 80% people who aren't going to graduate school, 20% of people who are. Well, weighting is a statistical way of being able to compare those two numbers and say saying graduate students or those who are going to graduate school are more likely to feel this way or less likely to feel this way than those who don't intend to go to graduate school. And it's a statistical way to even things out so you can properly compare those two. And that's the end of our sampling lectures.